Okay, so this week we're going to look at the different types of plastics. So we looked at thermosetting plastics, looked at thermoplastics. Now we're going to look at a few examples from each. Okay, from each category, and just two other things I want to mention: just branching and copolymers. Okay, so the first few there is we have PVC. So again, PVC is used on windows, used on gutters, things like that. It's very chemical resistant. That's why it's suitable for the likes of windows and things like that. So because it's very resistant to weather as well. So that's why it's used. It's also used in the likes of for medicines and things like that. Like if you buy a tub of paracetamol, it'll come in that. So it's used in car seats. The thing out there's a key word there. It's a thing known as a plasticizer. A plasticizer is something that's added to plastic to make it more flexible. Okay, in this state again, PVC in for pipes like that, PVC is extremely rigid. For car seats, again, fake leather car seats. Well, most car seats wouldn't be genuine leather. It adds this plasticizer. It makes it very flexible and allows it to stretch. Okay. Polypropylene is used for your lunch boxes, things like that. PP is the short word for it. So again, it's very strong regards when it comes to thermoplastics. And thermoplastics are much weaker than thermosetting plastics. It's durable and resistant to temperature. That's why you can microwave the lunch boxes. It's flexible. So again, the hinges here on the lunch boxes. It can be, again, when it's thin, it's flexible. When it's thick, it's rigid. And it's used in toys and hospital equipment. Okay, so it's polypropylene. Again, quite an expensive one. Quite a heavy one compared to other ones as well. Here we have, okay, so we have polythene or polyethylene. It's the same thing, different words, just two different words for the same thing. So these are used in what you have two different things. You have high density polyethylene and low density polyethylene. We would always have dealt with high density. High density is used for bottles. Okay, your drinks bottles, again, very safe for food. The likes of PVC isn't safe for food. It'll leach chemicals into the food. That's what PET, polyethylene, will not. Okay, so it can be made thin and clear. So again, you can see through the bottles. Hygienic, low melting point, so it's easy to recycle. Low density polyethylene is, well, low density is lighter. And then you have, so it's thinner and lower density. This is caused by branching. Okay, I'll go through branching in a few minutes. And then you have a high density polyethylene. It's just where the molecules are packed normally. Okay, so water bottles, lunchboxes, things like that. Again, when I talk about lunchboxes, I'm talking about your disposable lunchboxes. Branching, so again, branching is where we add an agent to the, so again, when I was discussing it, we were talking chain link molecules. They all go like that. No, nothing, just all straight lines. Well, all just lines. Branching, on the other hand, is where you have something along the lines of this. We add an agent. So you have one chain molecule forms. The agent has been added, and what that promotes is that promotes chains to actually come off the existing chain link molecule, and the two of them, you can see them intertwining there. Okay, so this promotes strength. This here, where they're intertwining, that promotes strength in the plastic, but it also allows them to be much lighter, much thinner, because the distance. Look at the distance between the chain link molecules here in comparison to over here. Okay, so it allows them. So that's what low density polyethylene. That's how we're able to make plastic bags and things like that, is by branching. Okay, so an agent needs to be added to it to promote these branches growing out of it. Okay, so promote strength as the branches intertwine. The next one I'm looking at, I'll just keep going through this, guys. The next one I'm looking at is a copolymer. Copolymer is the same as an alloy, only for plastics. So two plastics come together to make one. The most popular is ABS. So again, it's made of two different plastics. Again, you can change the ratio of the plastics. So again, one is usually it's 50-50. You get a certain thing. Again, it's where they mix materials of contrasting properties. So the likes of a tough and a flexible material, like one of the plastics you mix will be tough, the other one will be flexible. The higher percentage of the tough material there is, the more tougher it will be. But again, the flexibility is added there again just to make sure that it's to give it like it won't break on impact. When it's tough, won't break on impact. Flexibility there just gives because they want a certain amount of this property. Okay, it varies for several different properties. Okay, so you can see it's used in Lego, used in hard hats, used loads of different things, wastewater pipes, sewer pipes, all this sort of stuff. Okay, so copolymerization works very similar. It's addition. It's addition. So remember we were looking at the last day, we were looking at carbon, hydrogen, hydrogen. Then you had a double bond. This one will let on it's broke already. And then he connects on to, the two of them are very similar. You have hydrogen, 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 and I think that's an oxygen. Yeah, and so what you have there is you have two different molecules joined together. Again, the oxygen being the different one there. Okay, they're two different molecules for two different plastics. The way this works, again, addition, the two of them joined together to make one. Okay, so that's it for, I had a slide on thermosets. The only two thermosets you need to look at are urea formaldehyde and phenol formaldehyde. Both of them very similar, both used in, well, they're not both used, but some of the phenol formaldehyde is used in snooker balls and things like that. Urea formaldehyde is used in plug sockets, computer hardware, all this sort of stuff. So because they cannot catch fire, they will not melt, things like that. Okay, so that's it. So just jot down your notes, and again, anything that I went through here just to help you, make sure you jot that down, guys, when it comes to revising.